So here's our first case where we're dividing by a binomial. Again, what we want to do is focus on the leading terms. So the leading term here is a 2x, ignore the 1 for a bit, and focus on the 14x to the third. And you ask yourself, how many times will the 2x go into the 14x to the third? And so you clean it up, take your time, prime factorize if you need to. The 2 goes into the 14 7 times. The x's go into x squared times. So it would be 7x squared. So that's what you would expect to find here, 7x squared. Now after we're done with, we got that, now what we've got to do here is take the 7x and multiply it times this. Now here you have a binomial, so it has to be distributed to both. The 2x giving you a 14x to the third, and the 1 giving you a 7x squared. And then we're going to make a line here. We're going to change the signs here and change the signs and add. That's the same thing as subtracting. That way the leading terms cancel, and what we're left here is going to be a negative 20x squared. You can bring down the next guys, and the process starts all over again. If you can repeat that process over and over again, you can do long division. And if you can do long division, you can divide any polynomial by any other polynomial in this manner. Okay? Alright, talk is cheap. Let's get it done. So the next step is to have a 7x. Again, you multiply it here. That gives you 14x to the third and 7x squared. And then you change the signs so that these ones get canceled. And you bring down the next few items. Here, this is optional. You can just bring down one more, or you can bring down everything if you like. And then the process starts all over again. And now what we've got to look for is how many times will the 2x, the leading term, go into the 20x squared. And so you try to think, well, I have a 2x, how many times will it go into negative 20x squared? You see from the x's, one of the x's gets cancelled because I have x squared on the top and 1x on the bottom. From the numbers, I've got, from the coefficients, I've got a 2 and a negative 20. That would give me negative 10. That's what should go up here, negative 10x. That way when I multiply it out, I get negative 20x squared, and I would get negative 10x. And then when I change the signs, my leading term will get cancelled. That's what's supposed to happen. The leading term gets cancelled. And so you're just left with a negative 5x plus a 2 and blah blah blah. That's what we're thinking. Just repeat the process all over again. Look at the leading term. So talk is cheap. Let's do it. Write the negative 10, distribute it, change the signs, negative 5x, bring on the next one, and the process starts all over again. Now here we're going to be asking how many times will the 2x go into the negative 5x? Well, the x's would cancel, so you just get negative 5 halves. So that's what would go up here, negative 5 halves. When you distribute it, you got to be careful. It needs to be distributed to both. Every time we multiply this, it gets multiplied times all of the terms that you were dividing by. If there were 3 terms here, it would have to be distributed 3 terms. If there were 4 terms here, it would be distributed 4 terms. However many terms there are here, in this case there are 2, that's how many times you multiply this in there. Or how many times it's going to be multiplied times each of the terms. Not really, you know what I mean. Okay, so let's multiply this negative 5x. When you multiply that times that, because the 2 cancels and you get negative 5x. And you get negative 5 halves when you do this, and you change the signs. Here I go changing that sign, here I go changing that sign. This goes away, and now I've got 2 plus 5 halves. 2 can be rewritten as 4 halves if I wanted to. So I have the same denominator, and I have 4 halves and 5 halves. That would give me 9 halves. And now this is smaller than that one. This is degree 0, this is degree 1, so that would be my remainder. I would just write 9 halves over 2x plus 1, and we'd be done. Okay? Talk is cheap. Let's make it look nice here. Negative 5 halves goes in there that many times. 9 halves is your remainder. Told you. It's beautiful, right? Okay, let's try one more example. Let's try one more example here. How about this one? This time we're dividing by a trinomial into some 1, 2, 3, 4, 5 terms. Doesn't matter. All you do is look at one piece at a time, the leading terms. And so here you would just try to focus, how many times will the 2x squared go into the 4x to the 4th? Well, the x squared goes in there x squared times, and the 4 goes into there 2 times. And so once I have this 2x squared, which I got from comparing the leading terms, I got to take this and multiply it times this. But wait, this is 3 things, 3 terms. So it has to be distributed to 3 items, and those 3 items have to be written here. The first one will be a 4x to the fourth, the next one will be a negative 6x to the third, and the next one will be a 2x squared. 2x squared, negative 6x to the third, and 4x to the fourth. I changed the signs, because that, when you change the signs in add, that's the same thing as subtracting. Now I have a negative 10x to the third, and I have a 29x squared, and I bring down the other ones, everything else, and now the process starts all over again, but I've got a smaller creature here to deal with than I had started off with. We just have to repeat that pattern over and over again. Alright, talk is cheap, let's do it. So the 2 gets distributed there, multiply it out, that gives you negative 10, 29. Bring down the next one, and the process starts all over again. Optional step here, you can bring down everything from the top. So that now I'm just focusing on this piece right here. The 2x, how many times will it go into there? I think negative 10x to the third divided by 2x squared. I think this should be negative 5x. So it should be negative 5x. When I write that one, it's going to be multiplied times all of these, all 3 of them, and they have to be written here, all 3 items. So it'll be negative 5 times that, negative 10x to the third, negative 5x times this one, that would be 15x squared, negative 5x times 1, that would be negative 5x. Now I change the signs, change that sign, and change that sign. So now I get 14x squared, and here I get negative 21x. Bring down the next one, and the process starts all over again. It's nice, huh? It's easy. Alright, so that's what it looks like when you write it really neatly. How many times will the 2x squared go into there? Obviously 7 times, so you got the 7 there, multiplied in there. Change the signs, subtract the 3, that's a remainder, so you go plus 3 over 2x to the second power plus negative 3x plus 1. There's your remainder. The 3, I just popped it in there. It's a remainder all over this denominator. One more time, now we're showcasing the idea of placeholders, or the lack of. Sometimes your polynomial will jump from degree 4 piece to a degree 0. There's nothing in between. What do you do then? Well, the answer is nothing different. You just do the same thing. You focus on the leading terms. X to the fourth. How many times will x go into it? Well, it'll be x to the third. So you multiply that. That gives you x to the fourth minus x to the third. You change the signs. You bring down this guy minus that, and the process starts all over again. Now with this polynomial. So you focus on the leading terms. How many times will x go into x squared, x to the third? That will be x squared times, and that will give you x to the third. I'm multiplying it. Now I have to multiply 2 times. X squared gives you x to the third. Negative x squared. Sorry. And then you change the signs. Change the sign, change the sign. And the process starts all over again. And so on and so forth. So it will look like this. You add these, x squared, and then you have the minus 1 here, and the process starts all over again. How many times will the x go into there? Of course it will be x times, and that will give you x squared minus x. The process starts all over again. You change the sign, so it will give you x minus 1, and of course that will give you 1, and that will give you x minus 1. You change the signs, and that will give you a remainder 0. Okay, so nothing different here, just that you have to be careful. There's no placeholder. Sometimes people put like 0x to the third plus 0x squared plus 0x, just to help keep things lined up. You see how nice these columns line up? X squared, x squared, x squared columns. X to the third, x to the third, x to the third columns. Any case, so in this case it divides nicely. In fact, this is a famous polynomial. The famous polynomial goes like this: x to the fourth minus 1 divided by x minus 1 is equal to 1 plus x squared plus x to the third. That's what this phrase right here says. Or said differently, x to the 4 minus 1 is equal to x minus 1. If I multiply both sides by x minus 1, 1 plus x squared plus x to the third. Super famous. This is a geometric series polynomial number 4. But today we did it using long division. Alright, I think that will do it for us today. We'll see you guys here next time. Peace.